In this video, I'm going to walk you through the materials prep for Lesson 5 of Unit P1 from Open Sci-Ed. All right, there's a lot of prep for this lesson, and so let's jump right in. First of all, there are some handouts. I'm going to scroll up a little bit. So you will see that there is a power plant diagram handout. This will be used at the start of the lesson to get us into thinking about generators. We're going to use the handout to draw some energy transfer diagrams. And once we discover that generators are common in both of the diagrams and both of the models, we're going to lead into some investigations using generators. So this is the handout that will need to be printed out for the generator engineering task. This is the one that has 4 different challenges using generators with different amounts of coils wrapped around something like a cardboard tube. All right, let's go ahead and go down a little bit to talk about this setup. So right here, you can see this is what the handmade generator looks like. It has coils wrapped around a cardboard tube. There are some neodymium magnets inside, which I'll talk more about in a second. But as they spin, it transfers the energy from the changing magnetic fields to these coils that are wrapped around the cardboard tube. So when you spin this nail, the magnets are going to spin. There's a couple tricks in doing this. One is you really need to flick the nail. So you have to really kind of flick it to make it go fast. And when that happens, the LED that's connected to these wires will flicker on. It's not a real huge bright light, but you can see that the electricity is being transferred to the LED light. There will be several different generators that you make, and they will have a different amount of wraps around the coil, or different wrapped coils around the tube. This is the Preparing Generators material handout. And I will say that this is a pretty rough prep. I've done it before. We've used a hand drill, as it describes, to wrap quickly the wires into a coil around the tube. Practice and, give yourself plenty of time to do this. But I will say there is a company called ECA, and the school districts that I've worked with that use ECA, it comes with pre-made generators, and it saves a ton of time. So if you have not heard of ECA, this is one, every unit has one thing that has a lot of really, really hard prep. This is it for this unit. So you can purchase them pre-made, is what I'm saying. But if you don't have the money to do that and you're going to make your own, read through these materials and just really, the coils really matter, how tight they are, how close the wires are, and just just grab some patience. All right, there's a video here as well to help you prepare those generators. And so this will be, you can do it a couple different ways, but like a station. So each station will have a different generator with different wraps, and they can rotate around and kind of test the different stations. Or you can have each group report out what happened with their generator. We really, in our experiences, have found that only the one with the most amount of wraps has a good chance of getting that LED light on. The other ones don't seem to work quite as well, but try it out. Figure out how to do it, and definitely give yourself plenty of time. There's also a dissecting generator that is passed around at the beginning of the lesson. I gave you a sample to one on Amazon. It looks like this. What we're showing here is that at the very start of the lesson that there's some coils of wire in here, and it spins around this axle and it snaps together with a magnet. So we're kind of letting students discover that these are the materials that are in a generator before we then use these homemade generators with the same types of materials. Now, those neodymium magnets are really tough to get apart. One way that we have figured out is using a child scissors that has those blunt edges, and you kind of snip between the two magnets. So if they're tight together and you put the scissors on either end and you go like this, you can kind of separate them. But man, they are really tough to separate. You might want, if you have other magnets, you might want to see if they work. Students are going to I've spent a lot of time trying to get those neodymium magnets apart. So if you have ceramic magnets or coated magnets, they might work a little bit better. Again, play, see what you can figure out. But you will need a dissecting generator to pass around to kind of lead students towards that. So they say pass around 2, that's in the beginning. Then we use the homemade generators. And then after that, we're trying to figure out what is it in that generator that is creating or transferring energy to the light bulb. And so we look at different parts. And so you will need these small compasses, and we're going to use one of the homemade generators. You're going to first put, the homemade generator, you're not going to spin it, nothing happens. Then you put the coils with nothing happens. When you spin it, the compasses move. And you could take the magnets out and show that, the magnets also move the compasses. This is considered to be done as a whole class, and they're recording on a chart what you tried and what you figured out. This is that hand crank generator, and it barely moves the compasses. But then over here, you connect that hand crank generator to the wires. Make sure it has quite the distance, so it's not this generator that's making the compasses move. It's the electricity that's being generated in these wires to the coils, and the coils are making these compasses move. So what we're trying to figure out here is that there is some energy being transferred at a distance through fields, and the fields are what are making these magnets move, and the changing magnets are creating a changing field that's then transferring energy to the wires and changing it to electrical energy. So this is kind of let's take all the parts apart of the generator and see what is actually happening here in these parts to lead to that building understandings discussion. Okay, so if I scroll back up, there is a what we tried, what we saw T-chart. This is to just kind of go through on these different experiments, what we tried, what we figured out about the different parts of this generator, what's making the magnets move. And then I think that's it. This is a link to a hand crank generator if you don't have one. Kind of an expensive one. There are cheaper ones on Amazon, but sometimes they're not that great. So check out, see if you have any in your classroom left over. Most physics teachers do. So, all right, good luck. And this is a lot of fun with students, but you do need to kind of give a little bit of leeway as to what you want your expected results to be. And then just summarize when that kid and that group gets those lights lit, what did you do to get that light lit? All right, good luck.